Picture the serene yet menacing silhouette of Anak Krakatoa, rising from the Sunda Strait, a smoldering reminder of one of Earth's most infamous volcanic events. What if everything you thought you knew about Krakatoa was only part of the story? The 1883 eruption of Krakatoa is legendary. Its cataclysmic explosion sent shockwaves around the globe, triggered tsunamis that claimed tens of thousands of lives, and unleashed a sound so loud it was heard over 3,000 miles away. The eruption's ash-clouded skies painting sunsets in vivid hues and cooling the planet for years. But this dramatic moment, etched into history, is merely a single chapter in a far older, more complex narrative. Beneath Krakatoa's fiery reputation lies a forgotten history of ancient cataclysms that shaped not just the region, but the entire planet, in ways more profound than we've ever imagined. The 1883 eruption serves as our entry point. On August 26-27, Krakatoa unleashed a series of explosions, the most powerful equivalent to 200 megatons of TNT, over 13,000 times the force of the Hiroshima bomb. The resulting tsunamis devastated coastal communities in Indonesia, killing over 36,000 people. What if Krakatoa's story began long before 1883, rooted in geological upheavals that dwarfed even that monumental event? The island we know as Krakatoa is but a fragment of a much larger volcanic system, one that has been active for tens of thousands of years, reshaping landscapes, altering climates, and influencing human history in ways we are only beginning to understand. To uncover this forgotten history, we must journey back to the ancient cataclysms that set the stage for Krakatoa's fury, revealing a planet sculpted by fire, ash, and unrelenting geological power. Krakatoa sits within the Sunda Arc, a volatile chain of volcanoes formed by the subduction of the Indo-Australian plate beneath the Eurasian plate. This tectonic collision has fueled volcanic activity in the region for millions of years, with Krakatoa as one of its most dynamic players. Geological evidence suggests that the modern Krakatoa is merely the latest incarnation of a volcanic system that has erupted, collapsed, and reformed multiple times over hundreds of thousands of years. Long before the 1883 eruption, this system was responsible for cataclysms that reshaped the Sunda Strait and left lasting scars on the Earth. One of the most significant pre-1883 events occurred around 416 CE, when historical records from Java describe a massive eruption that darkened skies and triggered tsunamis. This event, often overshadowed by the 1883 disaster, may have separated the islands of Sumatra and Java, which were once connected by a land bridge. Sedimentary records and coral reef disruptions in the region support the idea of a colossal eruption, with waves that reshaped coastlines and displaced early human populations. This ancient cataclysm hints at Krakatoa's long history of destruction, far predating the modern era. Even earlier geological studies point to a massive eruption around 535-536 CE, potentially linked to Krakatoa or a nearby volcanic system. This event is associated with a global volcanic winter, where ash and aerosols blocked sunlight, causing crop failures, famines, and societal upheaval across Europe, Asia, and the Americas. Tree ring data from this period shows stunted growth, while ice core samples from Greenland and Antarctica reveal high levels of volcanic sulfates, confirming a major eruption. Some historians even speculate that this climatic disruption contributed to the collapse of civilizations, such as the Eastern Roman Empire's struggles and the onset of the Dark Ages in Europe. While pinpointing Krakatoa as the sole culprit remains debated, its role in this ancient catastrophe underscores its status as a planetary force. To understand Krakatoa's ancient power, we must delve into the science of its eruptions. Volcanoes like Krakatoa are driven by subduction, where one tectonic plate is forced beneath another, melting rock into magma that fuels explosive eruptions. Krakatoa's position in the Sunda Arc makes it particularly volatile, as the subducting Indo-Australian plate generates immense pressure and magma rich in silica, which creates highly explosive eruptions. Over millennia, these eruptions have built and destroyed islands, altered ocean currents, and influenced global climate. One of the most striking aspects of Krakatoa's ancient eruptions is their ability to trigger caldera-forming events. A caldera is a massive crater formed when a volcano's magma chamber empties, causing the surface to collapse. Geological surveys suggest that the modern Sunda Strait is the remnant of a prehistoric caldera formed by a super eruption tens of thousands of years ago. This event would have dwarfed the 1883 eruption, ejecting hundreds of cubic kilometers of material and reshaping the region's geography. Such super eruptions, while rare, have the power to alter Earth's climate for decades, disrupting ecosystems and human societies. Krakatoa's tsunamis are another hallmark of its cataclysmic history. The 1883 eruption generated waves up to 40 meters high, but ancient eruptions likely produced even larger tsunamis. Sedimentary deposits in Indonesia and beyond reveal evidence of massive waves that inundated coastlines, leaving behind layers of volcanic debris and marine sediment. These tsunamis would have devastated early human settlements, forcing migrations and shaping cultural narratives. In some Indonesian myths, tales of great floods and fiery mountains may echo these ancient disasters, preserving the memory of Krakatoa's wrath in oral traditions. Krakatoa's eruptions, both ancient and modern, have never been isolated events. Their impacts ripple across the globe, influencing climate, ecosystems, and human history. The 536 CE event, for instance, is believed to have caused a global cooling period that led to widespread crop failures. In Europe, chronicles from the time describe a sun that shone without brightness, while in China, records note snow in summer. These climatic shifts strained agricultural societies, contributing to famines and migrations that reshaped civilizations. Closer to home, Krakatoa's eruptions have sculpted the cultural and environmental landscape of Indonesia. The Sunda Strait, once a fertile land bridge, became a maritime corridor after ancient eruptions and tsunamis. This transformation influenced trade routes and cultural exchanges between Sumatra and Java, fostering the development of maritime kingdoms. The 416 CE eruption, for example, may have disrupted early trade networks, forcing communities to adapt to new geographic realities. Krakatoa's ash and aerosols also play a critical role in global climate. Volcanic eruptions inject sulfur dioxide into the stratosphere, where it forms aerosols that reflect sunlight, cooling the planet. The 1883 eruption's global cooling effect was well documented, but ancient eruptions likely had even greater impacts. Ice core data from Greenland shows spikes in volcanic sulfates corresponding to major eruptions, suggesting that Krakatoa's predecessors may have triggered prolonged cooling periods that altered ecosystems and human societies. Today, Anak Krakatoa, child of Krakatoa, stands as a testament to the volcano's enduring power. Emerging from the sea in 1927, this new island is the product of ongoing volcanic activity in the same caldera that collapsed in 1883. Anak Krakatoa's eruptions, while smaller, are frequent, reminding us that the forces that shaped its predecessor are still active. In 2018, Anak Krakatoa triggered a deadly tsunami, killing over 400 people and demonstrating that the region remains a hotspot of geological activity. The study of Anak Krakatoa offers clues to the ancient cataclysms that defined the region. By analyzing its eruptions and deposits, scientists can reconstruct the history of the Sunda Strait, piecing together the story of a volcanic system that has been active for millennia. Advanced technologies, such as satellite monitoring and seismic imaging, allow us to track Anak Krakatoa's growth and predict future eruptions, shedding light on the processes that drove its ancient predecessors. Krakatoa's story is more than a single eruption. It is a saga of Earth's unrelenting power, written in fire, ash, and stone. The 1883 eruption, while monumental, is but one moment in a history that spans tens of thousands of years. Ancient cataclysms, from the 416 CE eruption to the potential super-eruption of 535-536 CE, reveal a planet shaped by forces far greater than human history. These events altered landscapes, climates, and societies, leaving a legacy that continues to influence our world. By exploring Krakatoa's forgotten history, we gain a deeper appreciation for the dynamic planet we inhabit. Its eruptions remind us of nature's capacity for destruction and creation, forging islands, altering climates, and shaping human destiny. As Anak Krakatoa continues to rumble, it serves as a living link to this ancient past, urging us to uncover the stories buried in Earth's fiery depths. The true power of Krakatoa lies not just in its famous eruption, but in the untold cataclysms that have sculpted our world for millennia.